has a factor of 1 times itself. So I know I can say 1 times 12 equals 12. So I'm going to make a rainbow to connect 1 and 12. Next, and I'm going to write a comma here because we use commas to separate the numbers. Next, I would count from 1 to 2 and write down 2. And I think to myself, are there any numbers times 2 that equal 12? Yes, 2 times 6 equals 12. So I'm going to write a 6 over here, and remember I'm going to use a comma to separate the digits. I know that 2 times 6 equals 12. So I'll make a rainbow to connect those numbers. Go back over to the left, and with my counting, I count 1, 2, the next number is 3. Is there any number times 3 that equals 12? Yes, 3 times 4.
4. Do I see a pattern here?
Connect those. 3 times 4 equals 12. Now, I know that I'm done with my factor rainbow because when I start on the left and I'm counting 1, 2, 3, the next number would be 4. But I'm not going to put 4 right here on the left because 4 is already on the right. When I get to a number that's already on the right side of my rainbow, that's when I know that I'm finished. So now I can say that all of the factors of 12 are 1, 2, 3, 4, 6, and 12. Let's try another one. This time, we will try.
Does everybody see that? Does that make sense to you guys? Yeah. Right. Now, if I were to write out the multiples of that, what would I say? Who can give me one multiple? If I was to write a multiplication, what would I say? 1. Right here. Hold on.
1 times 12.
Equals.
12.
Give me another one.
3 times 4 equals 12.
Give me another one.
6 times 2 equals 12.
Good job. Right. You want to see another rainbow being done? All right. Let's watch one more.
Try to find all of the factors of 20. First, I know that any number has a factor of 1 in itself, so I'm going to make 1 and 20. And I'm spacing them very far apart because I don't know how many factors are going to be in the middle, and I want to make sure that I've left enough room. So let's connect the rainbow. 1 times 20. So I'm counting, and I say 1, 2. And I think, 2 times what equals 20? Is there anything I can multiply times 2 equals 20? Yes, 10. I take my 10 and my comma to separate my digits. And I know that 2 times 10 equals 20. Now I go back to my left side and I do my counting numbers. 1, 2, 3. I think to myself, is there anything times 3 that equals 20? Well, I know 3 times 10 is 30. That's way too much.
Can anybody tell me what times 3 give me 20? Kendra.
And 6.
No.
Think about it. What is 3 times 6?
15.
18. So will that give you 20?
No, close.
No. Close, but.
20. Evelina?
What about 10 times 2?
We got to, yeah, if you do it the reverse,
10 times
yes,
2
we could
equals
do.
20.
Yep, we could do it the backwards way, yes.
But we want to know what times 3 give me 20. What'd you say, Shariah? Nothing? See? Like you own something.
Since I know my multiples of 3, I know that 3 times 7 equals 21. That's pretty close, but it's not exactly 20. So I go down. 3 times 6 is 18. There's nothing that I can make 3 multiplied by to equal 20. So I know 3 is not a factor of 20, and I'm gonna mark it out. I go back to my left and I'm counting. Now I have 1, 2, 3, 4. I ask myself, is there anything times 4 that equals 20? Yes, 5. 4
Oh,
times
I see those
5.
fives. Everybody's holding the five.
So I will connect those with the rainbow. 4 times 5 equals 20. And I also know that's when it's time to stop. I'll put a comma to separate 4 and 5.
Because
It's time to stop because when I start on the left and I do my counting numbers, 1, 2, 3, 4, 5 would be the next number. And look, there it is already there. So I'm not going to write it another time. So now I've found that all of the factors of 20 are 1, 2, 4, 5, 10, and 20.
Okay. So what are the factors of 20? Give me one. Sophia. And 2 times what? Give me
2 times.
2 times 10.
Good job.
White.
4 times 5.
Good job.
1 times 20 equals 20.
Good
Yes.
job. All right.
And what are all those numbers called? Factors.
Factors. Good job.
All right.
All right.
But 20 is the equivalent.
All right. Now we're gonna move into the salt. Okay. Back it up.
In your big math book, we want to page 261.
A math book?
Big math book. Did I give you one? I haven't given you one. I think you count. 261. We out. So can you look on with her? This is our last chapter in volume 1, and then you'll get a brand new book in the next week. 61. Okay, everybody should have got a grid paper.
Yes.
Everybody got a grid paper?
I got 2.
You should have to.
We have
You've been
4.
to use-
Ms. Wilbur,
Yes,
can you please send Finn to the front office to leave for the day?
Ben is now in Miss Y class.
Thank you.
You two are partners. You and her are partners. Okay? Okay.
All right. Got them all paired?
Except Kendrick. Kendrick is going to work with
Do you have a partner?
you. Yes, no.
Wait, Peyton.
Thank you.
All right. 3 is company, buddy. 3 is company. All right.
So working with factors, on page 261, solve and share. It says, can I find the factor pair of a whole number? Can I also look for patterns to solve the problem? Solve and share question asks, fourth graders at Ames School have 24 carpet squares. What are all the different ways they can organize the carpet squares into a rectangle array? Remember, when y'all started this, you looking for the factor of 24. Then you're gonna put all the different factors together on your 3. With your partner, you have
Fourth
4
graders
minutes.
at the Ames School have 24 carpet squares. What are the different ways they can organize the carpet squares into a rectangular array? Solve this problem any way you choose.
You have 4 minutes.
You can use, remember, anyway, yes. If you like the rainbow strategy that you were shown, yes. You can use the grid. Yes, you have 4 minutes, so you better get started. 4 minutes, we're going to come around and see your thinking. Okay, move over so you can see something. Okay. Very You can do it on your grid paper, yes. You didn't mean that exactly, but that's what you said. Okay, we say what we mean and we mean what we say. Oh, thank you, that's very kind. I like how you said that. All right, let me see. Get started. When you take your test, are you going to be able to use that? No. So let's try to use a way that's that you can use on the test. Can you use this on the test? Yes. So should we use this way? Because you can do it. Why don't you use this on the test? Can you use the paper to use that? Like that. I like that. So which one? Which one's going to be a factor? Which one's going to go with that? If you're not to that point yet, then it would be. But if you're not to this point yet, then I would stay with your grade paper. Right? So let's do 2. Let's do 2. Grade paper. Remember? And then how many do we need to go across? Alright, so how many do we have to go across? So what is that factor? 2 and what? 2 and 12. Because if we're not to the rainbow part, then what should we do? Use our what? Use your grid paper, okay? Until you get it solid, still use your grid paper, okay? Okay. Alright, so down below, what are your factors? So write the number 24. Well, you know what I would do at the top? What number should you write at the top? So you know what you're finding the factors of, yeah. Always put that at the top. So you remember what you're finding the factors of. What are you finding the factors of? Okay, put your big number at the top. And what goes between each number? You gotta put a comma, because that almost looks like the number 24. If you don't have commas between your what? Between your numbers. Yeah, you gotta put, oh, wait a minute. Yeah. 8, 12. Yeah, remember? See? That's why you gotta put that comma there, because then you're gonna get confused. Alright, you got about a minute left. I like how you guys worked it out.
You're saying that way you're actually not full up later.
Time.
Keep going. I like what y'all doing.
Okay, where's that at?
Okay, once again, the problem says, fourth graders at Ames School have 24 carpet squares. What are all the different ways they can organize the carpet squares into a rectangular array?
I don't understand.
Right. Give me the number.
I know. This is the, I know, but this is the first thing. So Mason, I know, but this is the first thing we done. Okay?
12 times 2. So what you would do is, she said, I have problems with this part right here. Trying to remember my columns and my rows. I believe this is rows that going up and down, and columns are going sideways. So don't get mad at me if I mess up, because I be messing it part up. So she started with 2. So we're gonna go side by side. 1, 2, and then she said 12. We're gonna go 12 down. Two times 12 is
44.
Julie.
8 times
8 times 3. Okay. You went 8 first.
8 times 3. So she says 4.
Good job.
6 times 4.
6 times 4. There, no.
I got 1.
Atlanta.
1 times 24.
1 times 24. That's what I'm thinking.
It's just 24 down, that's it.
I believe it's the whole page. You see how we use the graph?
Yeah.
You also can switch it. 1 times 24 could have went sideways. It equals 1 times 24. Now one thing I can't do right here, it's hard for me to do, is that when you use your graph like this, also it's called an array. So you would put, this is 6, you would put 6 up at the top and 3 on the side. You get it? Then let you know that you're multiplying.
Yeah. So one way would be like if you were to do the box, what she's talking about, if you were to do the boxes. So if you were doing 6 across and 4 down, 6 and 4. See how the 6 is longer, showing that, and then your 4. Or if you were doing, this is your long one, 24 across. It's the same as her 24. This would have been 24 times 1. This would have been 1 times 24. See how it's flipped around? Or it could have been, this would have been this way, which would have been 4 and 6. See how the shorter side is just kind of switching it up. This is your array. This is it formed like an array. Same as like that. Everybody see the difference? You gotta go, baby.
How can you use arrays to find the factor pairs of a number? Think about this question during the lesson.
The music director is trying to find the best way to arrange the chairs for a performance. The chairs must be arranged in a rectangular array. How many different ways can the chairs be arranged into a rectangular array? Use grids to show all the ways the chairs can be arranged.
Okay. Instead of using the grid first, tell me, what ways can the chairs be arranged? 12. 12 is our base number. What are our factors of 12? One times 12. Why? 2 times 6. Yes. 3 times 4. What are all our factors? Right there. 1, 2, 3, 4, 6, 12. 12 times 1 give us 12. 2 times 6 give us 12. And 3 times 4 give us 12.
The problem states that the chairs must be arranged in a rectangular array. This means that there must be the same number of chairs in each row.
You have your paper.
Alright, so now you do it using the grid paper.
Use the grid.
Remember, we gave you 2 sheets. So now we want you to do it with the rays.
With your range, like I showed you on the board. When I did the
Sure, different ways to do it with the arrays.
red line.
Not a rainbow, with the arrays. Okay? So, kind of like this. And color in the box. Alright? You can use whichever one. Miss Taybor gave you, I gave you several sheets. Because you'll have this same graphing paper when you take the test. Alright, so you use your graph, yes. No, this is independent. Just do it at your seat. I'm gonna give an example of one. I'm gonna do 2 times 4. I'm gonna do 2 across in my row. Now I'm gonna do 4 down.
Nice touch.
So this is 2 and 2 and 6. So this is 2 and 6. What does 2 times 6 give me? 2 across, 6 down. This is an array. 2 and 6. Can y'all do array? Don't need to review that, huh? Okay, so look, take it right here. So you do 2, 1 right here. 2 boxes. That's your factor of 2. You're going to say 2 times 6. 5, 6. And back up. That's 2 times 6. That's your array. you'll get problems like this, and it'll say, what does this array equal? And how do you know what this array equals? You're gonna know it's 2 times what? 6, or you can count all the boxes, but the easiest way is just to say 2 times what? 2 times 6. Instead of going 1, 2, 3, 4, 5, 6, you know. Yes. Yes. It's perfect. You do it in the middle. You don't have to do it right in the corner like that. I was just trying to save space because I don't have a big grid paper.
Are we gonna do the exercise?
What does it say? As many ways as you can make. How many different arrays can you make out of 12? And we already know all the factors because we worked that out. So how many can you make? We know it's 1 times 12, 2 times 6, 3 times what? 4. So you can make how many? 1, 2, 3. You can make 3 arrays. Which one are you doing? 3 times what? Good job. Alright, you got it? Okay, where's my mask?
Madam, can you do? Huh? Can you do? I got
Pairs of numbers multiplied together to find a product are called factor pairs. Think about multiplication to decompose a number into its factors. How is a rectangular array of 12 chairs related to factors of 12? In a rectangular array of 12 chairs, the number of rows and the number of chairs in each row are factors of 12. You can make one row of 12 chairs, or 12 rows of one chair.
See a thumbs up.
1 and
So we all
12
get that
are
one?
factor pairs.
Yes? Good.
Is it always possible to make arrays with one row? Is it always possible to make arrays with one item in each row?
It's always gonna be that number, right? It's the number itself is a what? Is a factor, right?
Yeah.
Yes.
And 12 is the equivalent.
You're so smart.
Yes, no matter how many items there are, you can always put all of them in one row, or put one item in each row. You can also make 2 rows of 6 chairs, or 6 rows of 2 chairs.
Thumbs up
2
if
and
you
6
got that
are
one.
factor pairs.
Yeah, good job.
Is it always possible to make arrays with 2 rows, or arrays with 2 items in each row?
Is it always possible to do this one? Why don't you shaking your head? Tell me why. Why not? Why can't you do 93? I'm giving you a hint with 3. Why? Thank you. Yes, because if it's an odd number, it's odd. It doesn't break up what? Evenly. Can you split 93 evenly? No. No, you can't.
No, it is not always possible. For example, if you have 5 chairs, you would have 1 chair left over if you made an array with 2 rows. You can make 3 rows of 4 chairs, or 4 rows of 3 chairs. 3 and 4 are factor pairs.
Did you get this one?
Is
Yes.
it possible to make an array with 5 rows using 12 chairs?
Can you make an array with 5 chairs?
No.
No, because she just showed you. What's going to happen? One of them's going to be
Left out.
left out. Left out.
Possible to make arrays with 2 rows or arrays with 2 items in each row?
How many did 2 and 6? Thumbs up, 2 and 6, yes?
No, it is not always possible. For example, if you had 5 chairs, you would have 1 chair left over if you made an array with 2 rows. No, 5 rows leaves 2 chairs outside of the array, and 5 rows of 3 is too many chairs. So 5 is not a factor of 12. So there are 6 possible ways the 12 chairs can be arranged. The factors of 12 are 1, 2, 3, 4, 6, and 12. Now you know how to use arrays to find the factor pairs of a number.
Okay, let's practice.
Yes.
If I have 15, what are my factors?
5,
Hold on. Give me 1.
5 and 3.
5 and 3.
Irvin, give an example. What's another one? Is there another factor of 15? Just what? Think about multiplication. What can you do? What's the community property? What can you do? I'm tricking you. What can you do? Instead of saying 5 and 3, you could say what? 3 and 5. Or 5 and what? 1. But they are the only factors in there.
So you always know that you can flip them around. Like this could have been on top. It would have been 3, 5.
Because a good question they might ask you on a test would be, what are all the multiples? When they ask you the question, the multiples, they're going to ask you, what are the multiplication? They're going to say 1 times 5, 15 times 1, 3 times 5, or 5 times 5. They might give you like a whole bunch of questions with those possible answers. And you have to know that just because they're flipped, they're still the same one. Still the same answer, still the same problem. Those are good things to think about. Ooh, that's a good one.
Julie.
5 and 7.
Ooh. She started with big guns first. Started with the hardest factors first. Okay, remember we want to get score. Abby.
7 times 5.
Yeah, 7 times 5, so just flip it around.
Flip it around. It's long.
You know what?
1 times 35.
1 times 35. I'm just gonna draw this long line.
Draw that long array, that's 35.
And another one. Would there be another one? Okay. Making sure.
You know why? Why couldn't there be another one? It's really hard to do factors because what's in the ones place, guys? What kind of numbers in the ones place? Odd numbers. So there's not as many factors when you have odd numbers.
There's 2 odd numbers in the exact in there.
It is, yeah, there is 2. The tens and the ones have an odd number. All right, let's do, give me some factors that go into that one. 7 times 6? Uh-huh. Yeah. That's a good one. You got one? I like how a lot of you are working these out on your paper. Hocus, focus, hocus, focus, focus, buddy. Is this something you could do really well on? Today's the first day we're doing it. That's right, it's the first day we're doing it. Yeah.
That's a good one.
Yes.
That's a long one.
Yep, yep. You should be doing it all over. Yes.
This one stands for 21 times 2.
That's right. Remember that was in our multi-step problems. Remember? Last week that was one of the strategies you could use.
Me. 42.
Yeah.
42 times 1.
42 times 1.
A lot plus a lot.
Anybody know of any other? 2 and 21. So what are the factors? Let's call them out. What's the first one? Starting from the smallest to the greatest number. What's the smallest factor? 1. What's the next? 2. Ooh, 2. What's the next one?
6.
7. Oh no, 6. Oh, y'all got me. Then 7.
8.
Not 8. No, look at the board. You're not looking at the board. Then 20 what? 21.
42.
Then, yep, 42 we started with. All right. Good job. Okay. Now, let's see. What time are we done here? What time is this clock over?
3 o'clock.
2:55. Okay.
No, we don't.
All right.
$2.54.
What do we need?
Freddie, Clay, Evelina, Mason.
Mason. We all need to get on your test.
Bring up